We have seen that all the programs to be executed are permanently kept in the secondary memory, and whenever we need to execute a program, we should load it from the secondary memory to the main memory, and now it is no longer just a program, it will become a process in the main memory. The moment a new process is created in the main memory, it will get associated with a data structure called process control block or PCB or task control block. Each process will be associated with its own process control block, which keeps all the information related to that process. So each process will be having its own process control block, and the process control block is usually kept in the kernel space, not in the user space of the process. It contains all the information specific to the process, and it helps in context switching by keeping track of the current activity or the current status of the process. The architecture of the process control block may differ for different operating systems. Anyway, let's see generally which all information is kept in the process control block. There can be multiple processes in the main memory at the same time. So, in order to uniquely identify each and every process in the main memory, each process will be associated with a process number or process identification number, with the help of which we can distinguish each process from other processes. The next important information is the state of the process. We will discuss about the different process states in the next video. From the point of creation to the point of termination, the process can be moving from one state to another. Once a process is about to be created, we can say the process is in a new state, and once a process is created, it will move to the ready state, and once it gets to the processor or once it is being executed, it will move to the running state, and once the execution is over, it will move to the termination state. So from the point of creation to termination, the process can pass through different stages. So PCB keeps track of the current state of the process. Then program counter. The program counter within the process control block keeps track of the next instruction to be executed for that process. Suppose P1 is the process which is in execution now. Assume that P1 has completed the execution of the instructions I1, I2, I3 and I4. So the next instruction to be executed is I5. So the program counter within PCB will be pointing to the instruction I5. It will contain the address of the instruction 5. Assume that P1 is now under execution, so the processor is with the process P1. Hence, the processor program counter will also be pointing to the next instruction I5. But before executing I5, suppose here the processor switches to another process P3. As a result, the CPU program counter will be pointing to some instruction within the process P3. It means even though CPU program counter get updated, the information regarding what is the next instruction to be executed for the process P1, that information we have already saved in the program counter within the process control block of P1. So later when P1 is scheduled to run again, now we can restore the content of the program counter from its PCB to the CPU program counter and can resume the execution from instruction 5 onwards. So with this field in the process control block, we are able to keep track of what is the next instruction to be executed for a process at any time that process is scheduled to run. This is very helpful in context switching while a process is being executed. Anytime if the processor switches to another process, later when this process is scheduled to run again, we will be able to resume the execution from the instruction where we stopped. The process control block also keeps information about the registers, the CPU registers used by the process while it's being executed. This is also helpful while context switching. When the process is under execution, when the processor is allocated to a process, that process will be making use of the registers of the processor, the special purpose registers and the general purpose registers of the processor. Suppose P1 is the process now in execution and assume that P1 has completed the execution of instruction file. Until that time, P1 was making use of the registers R1, R2 and R3, and the contents of R1, R2 and R3 now according to P1 are 5, 10 and 15 respectively. Now before executing instruction 6, suppose the processor is switching to another process. Before the switch occurs, these registers and their contents will be stored to the process control block of the process P1. Because when this processor is allocated to some other process, those processes will be making use of these registers, the special purpose registers and the general purpose register. As a result, the contents of the registers get changed. Even then, after some time when P1 is scheduled to run again, P1 can identify that it was using these registers and these are the contents of the registers required for it to resume the execution from the next instruction onwards. Thus, when P1 is scheduled to run again, the contents of the registers from the process control block will be restored to the processor register and the process will resume the execution from the next instruction onwards. Next is memory management information. In memory management module of operating system, we have seen that the physical memory, the main memory space allocated to a process can be contiguous or non-contiguous. In contiguous memory allocation, we need the base address in the base register and the limit address in the limit register for address translation, for translating logical address to physical address. And in non-contiguous memory allocation, we make use of the page tables and segment tables for address translation. Such memory management information such as base register content and limit register content or page tables or segment tables, such information is kept in the process control block of the corresponding process. PCB also keeps track of the I/O devices and the resources allocated to the process and also the files opened by the process. It also keeps the CPU scheduling information such as priority of the process, pointers to the scheduling queues and so on. We will discuss about scheduling later. All these are the general information which is kept in the process control block.